Dear friends, in this video, I'm going to discuss another interesting problem in pricing analytics involving the situation of duopoly in economics. Here is the problem. It's a classic duopoly problem. There are two players, and I'm reading out the problem. The duopolies of the example are radio manufacturers producing identical sets. The total cost of an output of X sets per week is X square divided by 25 plus 3X plus 100 in each case. When the price is P, the market demand is X is equal to 75 minus 3P sets per week. Find the price output that will maximize the profit. This problem is adapted from R.G.D. Allen Mathematical Analysis for Economists. And for the sake of simplicity, let's assume the outputs are numbers as it is given, sets. And the price is in dollars, let's assume. You will have to find out the price output that will maximize the profit. Now, this situation involves two players, and we are assuming the simplest form to start with. Conjectural variations are zero, Cournot model. That is, the first player will think whatever may be my output, regardless of my output, the first duopolist will always have a fixed output. Similarly, the second player will think about the first player. And therefore, the situation is each one of them is thinking the output of the other is invariant to what I decide or what he decides. So that is the assumption. And we are going to work out the problem solution in the next slide. Step by step, I'm going to cover. X is equal to 75 minus 3P implies P is equal to 75 minus X by 3, which is equal to 75 minus X1 minus X2 by 3, because the output is shared between the two players, the two duopolists. So I will have to have X1 minus X2 here, minus X1 minus X2 divided by 3, which on simplification gives me 25 minus X1 upon 3 minus X2 upon 3. Output X is equal to X1 plus X2. Revenue for the first player, R1 equal to X1 into 25 minus X1 upon 3 minus X2 upon 3, because P is written in the form of X1 and X2 as a function of X1 and X2. So this is equal to, upon simplification, 25 X1 minus X1 squared upon 3 minus X1 X2 divided by 3. Cost for the first player, C1, because the cost is given in the previous slide and identical cost, and therefore we are putting here in the place of X1 squared divided by 25 plus 3X1 plus 100. This will be the cost of producing X1 sets for the first player. Profit for the first player, Y1, is therefore equal to revenue minus cost, R1 minus C1, which is equal to 25X1 minus X1 squared by 3 minus X1 X2 by 3 minus X1 squared by 25 minus 3X1 minus 100. Simply subtraction. Now, revenue for the second player, likewise we do, which will be X2 into 25 minus X1 upon 3 minus X2 upon 3, which is equal to 25X2 minus X2 squared by 3 minus X1 X2 by 3. Cost for the second player is C2 equal to X2 squared by 25 plus 3X2 plus 100. So profit for the second player, Y2 is equal to R2 minus C2, which is equal to likewise before 25x2 minus x2 squared by 3 minus x1 x2 divided by 3 minus x2 squared by 25 minus 3x2 minus 100. Now let me just go to calculus in the next slide. Y1 is equal to this. I'm writing from the previous slide, the profit of the first player. So Y2 is equal to this for the second player, this expression. Now dy1 by dx1 equal to 25, the differentiation we apply, this will be 25, this will be 2x1 upon 3, this will be x2 by 3, this will be 2x1 upon 25 minus 3. So 25 minus 2x1 by 3 minus x2 by 3 minus 2x1 by 25 minus 3 is equal to 0 upon simplification. We'll have to set the first derivative equal to 0. And this upon simplification becomes 56x1 plus 25x2 minus 1650 is equal to 0, equation number 1. Now let's do the second duopolist maxima problem. dy2 by dx2 is equal to 25 minus 2x2 by 3 minus x1 by 3 minus 2x2 by 25 minus 3 is equal to 0. By symmetry, you can write that, and it's fairly simple. Now, this upon simplification will yield the second equation, which is 56x2 plus 25x1 minus 1650 is equal to 0, which implies if I subtract 1 minus 2, the equation part, 56 into x1 minus x2 minus 25 into x1 minus x2 is equal to 0. This implies x1 is equal to x2. So the output is equally shared. And now substitute x1, x2, the value, substitute x1 for x2 in the first equation. So x2 will become x1. So 56x1 plus 25x1 is 81x1 is equal to 1650. Therefore, x1 is equal to 1650 divided by 81, 20.37. Likewise, x2 is equal to 20.37. Therefore, the output is the total of these two. I round it and say that 41 sets per week will be produced as total output, and it will be shared 20.37 plus 20.37. You can say 2020 or whatever, because the as number of sets produced cannot be a fraction. I am not rounding it in the beginning. I am rounding it as a total output. 41 is equally shared. You may say 20.37 if you wish, or 20 and 20 if you wish. But 41 is the rounding. Normally, we do in mathematics rounding at the end of the computation. Now, price is equal to 75 minus x1 minus x2, and the total is 41. Minus x1 minus x2, I'd add it, 41. So 75 minus 41 divided by 3. P is equal to 75 minus x by 3. So $11.33 is the price, and the profit, total profit, will be equal to, if you simplify this first expression and the second expression, this is the profit, and you will be getting 54.92 and then another 54.92, which is 109.84. And so the final answer is 110 rounded. That is the situation, and this is the solution to the problem. I hope you have enjoyed. This is the case where the duopoly, each one of the player assumes his output will be invariant to whatever the other person decides. And the cost is constant, same for both, and therefore we are getting it. Of course, the situations can change. The conjectural variation need not be zero. You can complicate it and do other challenging problems. I am just introducing how pricing analytics could be so fascinating. Thank you very much. We will see you soon in another video.